How's it going, guys? Today in this video, we're going to be going over Module 10.1, Day 2, where we're going to be talking about how to add and subtract rational expressions. So adding and subtracting rational expressions is going to be very similar to just adding and subtracting regular fractions. All we really need to do is we need to make sure the denominator is the same in both rational expressions, and then we just add or subtract the numerator. All right? And afterwards, we're going to have to identify any excluded values, and we do that before we actually simplify our answer. Okay? So let's go ahead and just get started. We're going to go straight to examples. On number 1, we have 6 all over x minus 1 plus 5x all over x squared minus 1. So first thing we need to do is we're going to factor out the denominator. Okay? So for 6 all over x minus 1, if we factor out the denominator, it just stays the same. X minus 1 is already simplified. But for 5x all over x squared minus 1, x squared minus 1 is a difference of squares, so it changes from x minus 1 to x plus 1. And once we factor out the denominators for both rational expressions, what we want to do is we want to look at the denominator of each expression, and we want to figure out, and we want to actually want to figure out, but rather we're going to compare them, and we're going to see what each expression is missing compared to the other one. For instance, on 6 all over x minus 1, if we compare that denominator with the x minus 1 times x plus 1, that 6 over x minus 1 doesn't have this x plus 1 that the other expression has. So if one expression is missing something in the denominator, you're going to multiply that expression with what it's missing. So for instance, the 6 all over x minus 1 is missing that x plus 1. So we're going to multiply that expression with the x plus 1. And when we do, we get 6x plus 6 all over x minus 1 times x plus 1. And now we're going to look at the other expression, the 5 all over x minus 1 times x plus 1, and we're going to compare that with the first expression that we have. Well, we can see that the 5 all over x minus 1, x plus 1 has every factor that the 6 all over x minus 1 has. The only factor in the denominator that 6 over x minus 1 has is that x minus 1, and we already have it on the second expression, so we don't need to add anything to the 5 all over x minus 1, x plus 1, so we just leave it alone. So what we're going to do now is we're going to combine our numerators. So our new expression that we just made, the 6x plus 6, all over the x minus 1, x plus 1, we're going to add to it the 5, which just would be 5x. Sorry about that. 5x all over x minus 1, x plus 1. Right, the denominators are the same now, so that means we can add like terms. So 6x plus 5x is 11x. And there's no constant term on the second expression, so the 6 just stays 6. And all of that all over x minus 1 times x plus 1. So before we simplify, what we want to do is we want to figure out what our excluded values of x are going to be. Okay? So we're going to look at the denominator, and we're going to set each factor in the denominator equal to 0. So x minus 1, when that equals 0, we get 1. And when x plus 1 equals 0, we get negative 1. So our excluded values of x are 1 and negative 1. So once we figure out our excluded values of x, then we're going to simplify the function. But we can see 11x plus 6 doesn't factor out, and there's nothing that can cancel out from the top or the bottom. So it's already completely simplified. So the 11x plus 6 all over x minus 1, x plus 1 is our simplified function. Okay, so let's go on to number 2. For number 2, we have 3x minus 6 all over x squared minus 16 minus 5x all over x plus 4. So again, we're going to factor out our denominators. We're not going to factor out the numerator because we need to add it to another numerator, so it's going to be a waste of our time to even factor it. So only focus on factoring the denominator. So x squared minus 16 factors out into x minus 4, x plus 4. And 5x all over x plus 4 doesn't factor out, or the x plus 4 doesn't factor out anyway. So we're just going to leave it as is. So now that we factor out the denominators, what we want to do is we want to compare them and see what each denominator is missing compared to the other one. With 3x minus 6, its denominator has everything that the other denominator has. The only thing the other denominator has is x plus 4, and the first expression already has it, so we don't need to mess with it. It just stays the same. And now for 5x all over x plus 4, if you compare that denominator with the first expression's denominator, we see that the 5x all over x plus 4 doesn't have the x minus 4 that the other expression has. So if it doesn't have that piece of the denominator, we need to multiply that expression with what it's missing, so we can make sure that the denominator has what it needs, so we can actually have a common denominator. Okay? So we end up getting 3x minus 6 all over x minus 4 times x plus 4. And all of that minus 5x times x is 5x squared minus 20x all over the x plus 4, x minus 4. All right, so now we're going to combine like terms. So 3x minus negative 20x, that's going to give us 23x, right? 3x minus negative 20x is the same thing as 3x plus positive 20x, or 23x. Negative 6 minus the 0 and the constant in the second expression is just going to be negative 6. And for the 5x squared, we don't have an x squared in the first expression, so it's very similar to just saying 0x squared plus 3x minus 6, or not similar, it's the exact same thing. And we can see 0x squared minus 5x squared is just a negative 5x squared. So you get negative 5x squared plus 23x minus 6. All that over the same denominator. The denominator doesn't change when you add fractions, so we just rewrite it. So now we need to see if negative 5x squared plus 23x minus 6 factors out. So we don't have a coefficient of 1 in front of the x squared. So we're going to multiply our a times our c term, or the negative 5 with the negative 6, which gives us a positive 30. And we need factors of 30 that add up to give us 23. There's no factors of 23, there's no factors of 30 that add up to give you 23. So this negative 5x squared plus 23x minus 6 is as simple as it's going to get. So what we're going to do now is figure out our excluded values. We actually should have figured that out before we tried simplifying it, but it didn't simplify anyway, so it's not a big deal. So we're going to figure out each excluded value by setting each factor in the denominator equal to 0. When x plus 4 equals 0, we get that x equals negative 4. And when x minus 4 equals 0, we get x equals 4. So x cannot equal negative 4 or 4, or our excluded values are negative 4 and positive 4. So let's go on to number 3 now. For number 3, we have 5 all over x plus 3 plus x squared all over x squared minus x minus 12. So same thing, we're going to factor out the denominators of each expression. X plus 3 is already factored out, so we're just going to rewrite that. And we're adding to it x squared all over x squared minus x minus 12 factors out into x minus 4 times x plus 3. So now we're going to compare the denominators of each expression, and we're going to see which expression is missing something that the other expression has. For 5 all over x plus 3, it doesn't have the x minus 4 that the other expression has, and we need to make sure it has it, so we're going to multiply the 5 all over x plus 3 with the x minus 4 that it's missing. And remember, it has to be x minus 4 over x minus 4, because we cannot change the value of the function, and x minus 4 over x minus 4 is just a 1, so we're not changing the value of the expression. Okay, and when we do that, we get 5x minus 20, and all of that over x plus 3 times x minus 4. Okay, and now if we look at the second expression, the x squared all over x minus 4, x plus 3, if we compare that denominator with the first one, we can see that it has everything that the first denominator has, so we don't need to change it. It can just stay the same. Okay, so if we rewrite our expressions, we have 5x all over 20, all divided by the x plus 3, x minus 4 in the denominator, and we're going to add to it the x squared all over x minus 4, x plus 3 from the beginning. X minus 4, x plus 3. All right. And now we're going to add the numerators. And when we do, we get x squared plus 5x minus 20 all over the denominator of x minus 4, x plus 3. So before we simplify, we need to figure out what our excluded values of x are going to be. So we're going to set each factor in the denominator equal to 0. So when x minus 4 equals 0, we're going to get x equals positive 4. And when x plus 3 equals 0, we get negative 3. So our excluded values of x are 4 and negative 3. And after we figure out our excluded values, then we want to simplify. And if we try simplifying x squared plus 5x minus 20, we can see that it's not going to simplify since there's no factors of negative 20 that add up to give you a positive 5. So this right here is our simplified expression as well. Okay? So let's keep on going. On to number 4. Number 4, we're going to do it the exact same way we've been doing it. Factor out the denominator, and then figure out what our common denominator is going to be. Minus 1 all over x minus 2. So if we compare the denominators of each expression, we can see that the first expression, the x squared over x minus 2, x plus 2, has every factor that the second expression has. The second expression only has an x minus 2 in the denominator, and the first expression has it, so we don't need to change the x squared all over x minus 2, x plus 2. It has everything that the first denominator has. But if we look at the second expression, it's missing the x plus 2 that the first denominator has. So if it's missing it, we need to add it, or rather multiply it, to make sure that it has that in the denominator. So if we rewrite our expressions now, the first one stayed the same, since it has everything that the second one has. And the second one becomes x plus 2 all over x minus 2 times x plus 2. So now we're going to subtract the numerators since the denominators are the same now. And when we do, we get x squared on the top. Then we get minus x and minus 2. And all of that over x minus 2 times x plus 2. So now that we simplified, or sorry, we didn't simplify, but rather when we figured out our difference of the two expressions, what we want to do is figure out our excluded values of x. We're going to do that before we try simplifying it. So we're going to set each factor in the denominator equal to 0. And when we do, the x minus 2 gives us an excluded value of 2. And the x plus 2 gives us an excluded value of negative 2. Set them equal to 0 and solve for x. So our excluded values of x are 2 and negative 2. Next, we're going to try to simplify our expression. So we're going to look at the top of the x squared minus x minus 2. That actually does factor out, and that's going to factor out into x minus 2 times x plus 1. We finally got a problem that factors out on the top. And we can see that if we rewrite the denominator, we actually have a pair of factors from the top and bottom that cancel out. That's the x minus 2. And when we cancel those out, we're left with x plus 1 over x plus 2. So our simplified expression is x plus 1 over x plus 2. And our excluded values are 2 and negative 2. So x cannot equal 2 or negative 2. All right, let's keep on going. Now we have number 5. So if we look at number 5, I'm going to go ahead and rewrite it. 5 over x plus 2x minus 1 over 3. We're going to compare the denominators of each expression, and we're going to see what it's missing. With 5 over x, it doesn't have a 3 in the denominator like the other expression has, right? 2x minus 1 over 3 has a 3 in the denominator, but 5 over x doesn't have that 3. So that means we need to multiply the 5 over x with 3 over 3. It's missing a 3 in the denominator, so we're going to put it in there. For 2x minus 1 over 3, if you compare that with 5 over x, it doesn't have the x that the 5 over x has. So we need to add it in there, or multiply it in there, whatever you want to say. So we're going to multiply the second expression with x over x. That way we get the x in the denominator that we want, and for the 5 over x, we're getting the 3 in the denominator that we need. So 5 times 3 is 15. All of that over 3x. And if we add to it, we're going to multiply the 2x minus 1 with x. That gives us 2x squared minus x all over 3x. So we're going to add the numerators. And when we do, we get 2x squared minus x plus 15. All of that over 3x. So now we're going to see, before we actually try to simplify it, we're going to figure out our excluded values. So to figure out our excluded values, we're going to set each factor in the denominator equal to 0. The only factor in the denominator is that 3x. Remember, anything with a variable in it in factor form is going to be a factor. So 3x, when we set that equal to 0, and solve for x, we're going to divide by 3 on both sides, and we get that x equals 0. 0 divided by 3 is just 0. So we know our only excluded value of x is going to be 0. So x cannot equal 0. After that, we're going to see if our 2x squared minus x plus 15 can actually factor out. We don't have a 1 in the a value, so we're going to do a times our c value, 2 times 15. That's 30. And we want factors of 30 that add up to give us -1. There's no possible factors of 30 that add up to give us -1. So that means our 2x squared minus x plus 15 is our simplified form of the function, or of the expression. So our excluded value is 0, and 2x squared minus x plus 15 all over 3x is our simplified form of this expression. Let's keep on going. Number 6, I'm going to leave that for you guys to do on your own. It is a relatively hard problem. You're not going to see anything like this on your quiz, nothing this difficult, I don't think. But I think it's very good practice, so I'll leave that for you guys to do on your own. And you can double check your answer with the key online. But we're going to keep on going. I'm going to leave 7 for you guys to do on your own as well. It's not going to be anything different than what we've been doing. So I'm going to leave that for you guys to do. But we're going to go on to number 8, because this is not in your notes. So you guys are going to have to write this down on by yourselves. But for number 8, we have 5 all over 10m minus 8 over 30m squared. So what we want to do is we want to find our least common denominator of this expression. We want to figure out the smallest possible denominator value so we can actually subtract these two expressions from each other. And our least common denominator here is actually going to be 30m squared, because 3m is the smallest possible value we can multiply 5 over 10m with to get 30m squared. Okay, so our least common denominator here is going to be 30m squared. And to get that, we're going to multiply the 5 all over 10m with 3m over 3m to give us 15m all over 30m squared. And 8 over 30m squared already has a 30m squared in the denominator, so we don't need to mess with it. So if we rewrite both of these expressions, our new expression is 15m all over 30m squared. And we're going to subtract from it 8 all over 30m squared. So 15m minus 8 is just 15m minus 8. And that's all going to be over 30m squared. All right, and before we simplify this, or see if we can simplify it, we're going to figure out our excluded values of x first. So our factor in the denominator, or our only factor in the denominator, is 30m squared. We're going to set that equal to 0. And we solve this out for m. We divide by 30. We get m squared equals 0. And the square root of 0 is just 0. So m just equals 0. So our only excluded value of m is 0. And for 15m minus 8 all over 30m squared, we cannot reduce the top anyway. We cannot simplify this expression anymore than it's already simplified. So that 15m minus 8, all over 30m squared is our most simplified form of this expression. So we're done there, and that's what our answer to number 8 is going to be. And if you're watching this video, I'm going to assume you haven't done the homework yet. So there is a correction we need to make if you haven't heard. For number 1, it should be x squared minus x minus 6 for number 1. So if you haven't corrected that, you haven't done the homework yet, please make that correction. And that's about it for this video, guys. Hopefully it helped. And that's about it.